Physics is hard, but with me, you'll learn how to physics and not cry. Okay, so today we'll be learning about thermodynamics, and if you know anything about Latin prefixes and suffixes, you'll know that we're analyzing the transfer of heat and other forms of energy. We won't talk about all of it to make sure that we aren't boring you, but we will give you a concept overview and the first two laws. Thermodynamics is a branch of physical science that deals with the relations between heat and other forms of energy. That being said, it sounds like burning to death while being vomited on, but I promise it's not that bad. Here are some flash facts about thermodynamics. The heat and energy transfer is known as the internal energy of a system. A system is a set of particles or interacting components considered to be a distinct physical entity for the purpose of study. In a system, three things are being done. Work is either being done on it, by it, or it's not even doing any work at all.
Like me.
Like me. Thermodynamics has four laws attached to it. A law being considered a simple statement of an observable physical phenomenon that has no underlying, more basic reason for being except that the most accurate observations have always proved to be true. Okay, and flashbacks. Flashbacks. In the first law of thermodynamics, there are four types of systems where the properties of a system can change according to the conservation of energy. Isobaric, isovolumetric, isothermal, and adiabatic. What? Adiabatic. In each system, a property, either volume, pressure, temperature, or heat, is held constant, while the other three change. This law states that the work performed upon the system during any adithermal transformation depends only upon the change of state affected, and it is independent of the intermediate states throughout which the system passes. Bop. In the isobaric system, pressure is held constant. In the isovolumetric system, volume is held constant. In the isothermal process, temperature is held constant. And in the adiabatic process, heat is neither added or removed. So it's held constant. Diabatic. It's time to play a game. Which system are you today? Are you doing work? If so, you are an isothermal process.
Adding heat, though.
You having work done on you? If so, you are removing heat in an isothermal process. Are you not doing anything at all? If so, you're an isovolumetric process. You see, I know I'm throwing a lot of information at you, but I swear it's not my idea. But here's some more information! The second law of thermodynamics is the entropy of an isolated system not in equilibrium will tend to increase over time, approaching a maximum value at equilibrium. You're probably asking yourself, what the heck is entropy? Or what the heck is an isolated system? Or what the heck is equilibrium? Or what the heck is happening? Because I still don't have a clue. Well, let me explain it. Entropy is basically a measurement of the disorderliness of a system, which means that if a system is not in equilibrium, the disorderliness will increase over time. Think about one of your friends that does not have their stuff together, and they don't have any way to get their stuff together. They will continue to not have their stuff together. LOL at me. An isolated system is when a system is far away from another system, so it does not interact. Or when a system is walled off from the rest of the world, so no energy or matter is able to pass through and enter the system. Making sure your system is isolated will allow for any error to be minimized. Thermodynamics equilibrium is when a system is mechanically and chemically Thermodynamics equilibrium is when a system is in mechanical and chemical equilibrium, and there is no spontaneous change in any of its properties. This means that when a system is in equilibrium, the temperature, volume, pressure, and heat does not change. Not so bad now, is it? If we insert the definitions into the actual law itself, it states, the disorderliness of a system is not affected by anything outside of it that is changing spontaneously and will increase over time and hit the maximum disorderliness when it is no longer spontaneous and random. Makes sense. There is a lot more to learn regarding the realm of thermodynamics, but I'll spare you an hour-long video. Join us next week. Nope, I don't like that. You can join us next week when we cover how to create a proper meme using proper meme format. Thanks for watching.